So let's now discuss merits. Merits of the mean. Sorry, not merits of mean, merits of mode. Merits and demerits of mode is very similar to merits and demerits of median. So the first, not affected, not unduly affected by extreme values, right? It is only the arithmetic mean that gets affected by the extreme values. Both median and mode are not affected by extreme values. Simple to understand, easy to calculate, right? You just have to look for the class or the value with the highest frequency and you can locate the mode. It is most typical, or it has the most representative value among all the most typical or representative value among all the other measures of central tendency. It can be used for open-ended data, right? We are only dealing with the central class or the central value, so open-ended data does not pose a problem for calculation or location of mode. It can be determined graphically, right? Since if you have the frequency distribution curve, all you need to look, so this is my value, x value, and if this is the frequency curve, on the y-axis just simply locate for the peak, and the peak is the mode. So graphically very easy to determine. The peak, read the corresponding x value, and that would be your x naught or your mode. Very useful for describing qualitative data. Right? So if I want to find which is the model brand of smartphones being used, what I'll do, I will ask all of you to report which brand you use. Is it Redmi? Is it Nokia? Is it Honor? Is it Motorola? And so on. And whichever brand has the highest frequency is my model brand. Remember, when I'm saying and the highest frequency will be the model brand of smartphones used, right? So very good, very ideal for dealing with qualitative data. Now moving on to demerits of the mode. First, very important thing, there is no rigidly defined formula. Not rigidly defined. Similar to median, unlike the arithmetic mean, and it is not based on all data, on all items of data. So if you take the tail end of the distribution and change a few values here and there in the tail end, it will not affect the main model class, and it will not be reflected. These changes will not be reflected in the value of the mode. So the ability of this model value to represent the sample is a little limited in that sense, and cannot be algebraically manipulated. So if I know the two modes of two model distribution of smartphone brand of third sem BA and third sem MA, I cannot combine it all the time. cannot be algebraically manipulated. Okay. Another point from the guidebook. It might be difficult to calculate in some cases, especially if you have large values and you have to classify them, you have to group them, take the frequency analysis and so on. So that's one of the things that they say. Actually, I don't really like this particular point. In the merits, they say it's easy to calculate, and in the demerits, they say sometimes it is tough to calculate. Okay? Sometimes. It all depends on the kind of data. It all actually depends on the kind of data and the number of observations you have in the data and so on. Not as stable as the arithmetic mean. Remember, when I'm talking about stability, I'm always talking about sampling stability. That is, if I have the same population and I take different samples from the same population, and every time I calculate the mode for each sample that I have taken. If all these samples come from the same population, the model values of which all these samples should be close to each other. Now, this condition is satisfied much more in the case of arithmetic mean, but not so much in the case of the mode, and almost not at all in the case of median. The value of the mode and median will depend a lot on how the sample is taken, even though you have taken these different samples from the same population. Okay. Now, another point, unlike the other measures of central tendency, sometimes the mode value might be ill-defined in some sense. What I mean is, sometimes your frequency distribution table does not really look, or frequency distribution curve won't really look like this. Sometimes you have more than one mode, maybe a data like this, and then there will be confusion whether to take this mode or this mode, because as you can see, both have quite close to each other but not really equal to. They have a clustering around this and high frequency around both these values, around x and x dash. So in such situations, which one to select, on what basis to select, the conditions are not very clear. While it does allow dealing with qualitative variables, it has limited use in other areas. So like you can have a mode size of family, a mode brand of smartphone, but when it comes to, say, values like GDP, comparing GDP of different nations, or comparing heights of different students, it is tough to come up with the model value, and it doesn't make as much sense as, say, arithmetic mean would make. So it has limited use. But yeah, for qualitative data, I always prefer mode. So which brand of shoes do you prefer? Which brand of smartphone do you prefer? Which cell phone connection do people mostly prefer? Which size of shoe is mostly sold, and so on? We find the model value very useful. But more quantitative variables such as this sort, which are widely distributed continuous variables, heights, weights, and so on, the model value might not be ideal measure of central tendency. So that's it.